All right, welcome back everyone. We have 9.3 trig equations part 1. This will be part of a two-part series. Now, you guessed it, your learning goal is to solve trig equations. And look at that, we're already into a problem. All right, so we got some new things going on here. So, solve the trig equations in the interval of 0 to 2 pi, okay? And of course, as always, once I look at this, I realize that this should just be a parenthesis instead of a bracket, right? Meaning that we want to solve for x from 0 and including 0 to 2 pi, but not including 2 pi. And the reason why we don't include 2 pi is if you look at the unit circle, 0 and 2 pi is the same exact place. So why include it twice? Okay. And then we want to write our solution in radians. Now, the biggest reason why we're specifying between 0 and 2 pi is if you think about it, apologize for the blurriness of this, but if you think about this at pi over 4, or let's use 30 degrees. At 30 degrees for sine of x, we could say that the answer would be 1/2. Well, if we go a full 360 and then another 30 to 390, we would also say that that's 1/2. So, again, we want to get rid of duplicate answers, okay? Now, what we're going to do is we're going to learn how to solve a trig equation. Now, the first goal when you're doing this is to get x by itself, okay? And in order to do that, sometimes you might have to get the trig value of x, or whatever variable it is, by itself first. So if you look at this next problem, we'll have other stuff going on. Our goal is really to get it to look like this, where it's a trig of x is equal to a single number. All right. When you get to this situation, you take the inverse of both sides, like you normally would, right? There we go, of this. And that would cancel out your sign, and you'd be left with x is equal to the inverse sine of 1/2. Now, of course, when you use a calculator, you could do this, you could get an answer, but think about this. What we're saying is that when we take the sine of an input of x, our output is 1/2. So if I have our output, our inverse takes us back, which means all I have to do when I have the inverse sine of x of 1/2 is go to where go to where 1/2 is for sine on your unit circle. So I go here, and I see it here, right? But I don't just see it there, I see it here. Now you may be looking at the bottom too, you see negative 1/2 here and here. However, these are negative, so these are not answers. Okay, so let's recap something here. Our inverse means we were asking a reverse question. What was the degree? What was the radian that brought us to 1/2? So that would be pi over 6. And that would be, 5 pi over 6. So we have two answers. So x is equal to pi over 6, and x is equal to 5 pi over 6. And that's it. All right? Now, let's recap here. I don't feel like I feel like I was kind of jumping all over the place trying to explain this. All right? In a bigger problem, your goal is to set something up like this. The trig value of your input is equal to a number. You take the inverse, you get the x by itself, right? And then you look for this number on the unit circle. If it's sine that you're doing, obviously you're looking for the y's. If it was cosine, you're obviously looking for the x, and you're finding the radians that get you there, okay? And you're only going around that circle one time because we're doing it over the interval of 0 to 2 pi. Okay, let's do this one, and then I'll give you guys one to do. All right, now we do have a little bit more stuff going on. So our first goal would be to get cosine of x or cosine of theta by itself. We have two of them, so we're going to bring them to the same side. A lot of the times it's kind of like we have to set it equal to 0 and then move some more things around. So I'm going to add this cosine here. I'm going to add it here. Cancels. I'm going to get 2 cosine of theta plus the square root of 2 is equal to 0. And then I'm going to solve for cosine theta. So I'm minus the square root of 2 to both sides. Cancels, and I have 2 cosine theta equals negative square root of 2. And then I divide the 2 to both sides, cancels, and I'm going to have cosine theta equals negative square root of 2 over 2. Okay. All right. Now we're at that point where we would take the inverse, which I'm just going to go like this. Okay, so I don't have to write it all out. That's, as if I wrote cosine inverse, right? Cancels that out. And I'm going to get something like, theta is equal to, and this is where I'm talking about my answers. All right. So I'm going to go to my graph. I'm going to look for, or my unit circle. I'm going to look for all the negative square root of 2's over 2's for cosine. So we're looking for x. So I'm going to go here. I see positives, not what I want. But here, look, my x1's negative, my y1's positive. This is perfect because I only care about the x1. So this is an answer. Let's do that in green. That's an answer. I find another one here for x. That's an answer. However, these ones are not answers because they're positive. All right, so be careful on that. So I have two answers. 3 pi over 4, 5 pi over 4. So 3 pi over 4 and 5 pi over 4. And that's it. Not too bad, right? Now you may be wondering, why are all these up here if we seem to not need them, right? Sometimes you're going to get some longer trig equations that might require these, okay? Okay, so I know I said to give you one soon. I'm going to do this one because this brings some new stuff to the table here, okay? For starters, we have secant. Secant's not on the unit circle, but it is 1 over cosine. So you could do this one of two ways. You could sit there and you could put it in terms of cosine to make it easier when you get to the unit circle, or you could solve it as secant and then just know that your answers need to be, 1 over, right? So because for cosine, you have to look at the graph and go 1 over this would give me what secant gave me, okay? I just prefer to put it in cosine. It's a little bit more work up front, but easier to think about when you get to your unit circle, okay? So I'm going to put this as cosine. So 1 over cosine squared of beta equals 2. I have to multiply cosine to both sides because I got to get it out of the denominator's place. I cancel. I get 1 is equal to 2 times cosine squared beta. Divide by 2, divide by 2. And I'm going to flip this. You get cosine squared beta equals 1 over 2. You take the square root, you take the square root, and you get cosine of beta equals the square root of 1 over 2. However, plus or minus. You just took the square root of a number. Therefore, there's two answers, right? The plus square root of 1 over 2 and the minus square root of 1 over 2. Now, when you get into this situation, there's no square root of 1 over 2 on the graph, on your unit circle, I mean. So you're going to have to rationalize this, right? Let's simplify this. I'm going to forget about the positive and negative for a second and bring that back in. I can split that square root up to the numerator and the denominator like we've done earlier this year. So that's square root of 1 over square root of 2. All right. Now square root of 1 is just 1, and square root of 2, well, we don't know what square root of 2 is, but we know we can't have that into the denominator's place, so we rationalize it by multiplying by square root of 2 over square root of 2. Oops. Now, that gives us square root of 2 on top and just the number 2 on bottom. So our answer here is really cosine of beta equals plus or minus the square root of 2 over 2. We go ahead and we take the inverse, which I'm just writing like this now, cancels, and we get beta is equal to the inverse of plus or minus the square root of 2 over 2. Now this is cosine, so we're looking for all the x's, but we're looking for all the x values that are positive square root of 2 over 2 and negative 2 over 2. Negative square root of 2 over 2. So I go here, and that's going to be 4 different points, right? I see the positive square root of 2 over 2 here, the negative here, and the positive here. So I got 4 answers. I got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so beta is equal to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and you have 4 answers. Okay? These things are going to happen more often when you see that square root. And this one, you didn't see that. We could only go off of that it was just negative because there was no square root of 2. Okay. Now, this problem here includes a little bit of everything. I want you guys to go ahead and give this a try. Remember, this is tangent, so your answer is not explicitly on that graph, and you do have a square, so you will have to square root and consider that in your answer. So give it a pause and give it a try. Okay, so when you got in this situation right here, you solve for your tan x, so you add 1 to both sides, it cancels. You get 3 tan squared x equals 1. You divide both sides by 3, cancels. You get tan squared x is equal to 1 over 3. Okay? You take the square root, cancels out the square. You're left with tan x equals the square root of 1 over the square root of 3. You rationalize that. All right, and I'm just remember that 1 is square root of 1 is just 1, so we're going to treat it like a 1 right now. And you get tan x is equal to the square root of 3 over 3. Now, we did take a plus or minus, or a square root, so we get a plus or minus here. So let's throw that in. Plus or minus, plus or minus. All right. So we need to look for both those situations where it is, the square root of 3 over 3. Now, here's where things get difficult about this one. This is not explicitly on there, so we're going to have to go to the graph and take sine divided by cosine and see if we can find that answer of square root of 3 over 3. Now, when we go over here and we look here, there's a lot of choices that we could make. So, I don't want to test all of them. Well, let's start to think about this. This first one here has a square root of 3 in it. This one does not. So, this one's never going to give us a square root of 3 in the answer. So let's go ahead and let's cross out all of those that are just those with only the 2's. It can't be our 0's and our 1's, right? And so we have to ask ourselves, is it the one where we take the square root of 3 over 2 and divide it by the 1/2? Or is it the one where we take the 1/2 and divide it by the square root of 3 over 2? And you're going to see that happen in 4 different places. It's just this question here of which one it is the same question that plays out here, that plays out here, and plays out here. Okay, because watch what happens if I trace this one over. It's the same thing. I would still take a 1/2 and divide it by a square root of 3 over 2. There's just a different combination of positive and negatives. This one is also, nope, that one's not. This one is also the same thing because I'm taking 1/2 and I'm divided by the square root of 3 over 2. So I really just have to ask myself, is it this one or is it this one? And then go find all the matching ones. All right. So I'm going to do this first one up here. I'm going to do square root of 3 over 2 divided by 1/2 because remember doing sine divided by cosine. Keep, change, flip. Square root of 3 times 2 over 1. 2's cancel. I get square root of 3. Well, that's close, but I need a square root of 3 over 3. So let's try the other one. 1/2 divided by square root of 3 over 2. Keep, change, flip. You get 1/2 times 2 over the square root of 3. The 2's cancel. You get 1 over the square root of 3. Now, look back here for a second. We had that exact situation, a 1 over a square root of 3. So we know that when we rationalize that, we get a square root of 3 over 3. However, I'm going to go over here and do it anyways. Multiply by square root of 3 over square root of 3. Okay, and that gives us square root of 3 over 3. So that is the right one. So my answer here is definitely pi over 6. Let's do that in green. It's definitely pi over 6, but it's all the other ones too that have 1/2 divided by the other. Because remember, our answer here was plus and minus. And so these other ones just give us a different combination of pluses and minuses. So this one will give us the -1. This one will give us a +1. And this one will give us the -1. So we have pi over 6. We have 5 pi over 6, we have 7 pi over 6, and we have 11 pi over 6 as our answers. So that was x. Sorry, I know I didn't do the inverse, but I'm sure by now you realize that that is done. So x is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, and that's it. All right, let's do the last one, okay? Now this one's a little bit tougher and it brings in a different situation, so it's very, very important that, you focus on this one because You're gonna have to do this sometimes. All right. We got a lot more going on. We got multiple trig values. Okay. So what we want to do is we want to get this in a factoring situation where we can use our zero product property rule. What that means is, think back to your quadratic. If I had, let's do 2x squared minus, let's just get rid of the numbers there. Let's say I had x to the power 4 minus x to the power 2 equals 0. I could sit here and I could factor, go, hey, wait a minute, I could take x squared out of this, right? And this would be x squared times x squared minus 1 equals 0. And then you play the cover game. You set up x squared equals 0. You solve and you do x squared minus 1 equals 0 and you solve. You get two situations of that zero product property. That's what we're going to want to try and do here. So we need to get this equal to 0 by minusing our 2 cotangent x to both sides. And so we get cotangent x times cosine squared x minus 2 cotangent x equals 0. Okay? Now, when we get to this situation, we need to factor out, kind of like we would have here. We would have divided out, an x squared, right? We have to ask ourselves, what is in both these terms? And that's cotangent. So we divide our cotangent out, cotangent x, cancels and it cancels, and we're left with cotangent x times cosine squared x minus 2 equals 0. Now we play the cover game. We set up one equation, cotangent x is equal to 0, and we set up the other one, cosine squared x minus 2 equals 0, and we solve them accordingly. Now here, cotangent x, we're saying that we have cosine of x divided by sine of x is equal to 0. Okay, so we go to our graph here, our unit circle. It's kind of like graphs, got a coordinate plane on it, right? And we ask ourselves, what situation will we take cosine divided by sine and get 0? Well, it's not this one, because 1 divided by 0 is undefined. But this one, we get that situation. 0 divided by 1 is 0. And this one, we get the same thing too. Even though there's a negative there, 0 can't be negative. But then again, here we get undefined also because we get negative 1 divided by 0. So far we have two answers, x over 2 and 3 pi over 2. So x is equal to x over 2 and 3 pi over 2. Now in this situation, I would have, taken the inverse, okay? But I guess I just keep skipping that step, right? So here we go, we have one set of answers. Now we're going to do this one. We're going to add the 2 to both sides, and we're going to get cosine squared x equals 2, right? Take the square root, cancels. We're going to get cosine x equals the square root of 2, plus or minus square root of 2. Okay, you would take the inverse, and you get x is equal to the inverse of plus or minus the square root of 2. Well, we go to our graph, unit circle, and there is no place where we can get just the square root of 2 on this unit circle. And so our answer for this one would be undefined. All right, so we would just have these answers. It doesn't always work out this way, where one of them will give you an undefined, but it is possible that that would happen. This is a situation that could happen, and you need to pay attention to this situation when you're doing your notes or doing your assignments, and know that if you get to one, you're like, but it's not on the unit circle, light bulb should go off at that moment. Undefined. Okay? All right, you guys, I hope you enjoyed it, and hope you learned something, and good luck. See you guys next time.